So we're going to try and polish things today. The nice thing is there's no, if you did use spring break wisely, at least to some extent for pre-cal, because I know you could have been wise in other ways, like by getting rest, you needed that, by hopefully having a little bit of fun, by maybe catching up in other subjects too, but hopefully you were able to be at least somewhat wise in pre-cal. And if you were somewhat wise in pre-cal and listened to my direction before we left, you have your 9-5 fully attempted, you're ready to grade. You have your test review, at least partially attempted, to figure out what questions that you had. And then we can kind of get out our notes in a little bit and highlight the important stuff, and then just tonight kind of make sure everything's good for tomorrow. If you weren't wise with your spring break, you're going to need to work tonight on the review, hopefully not on 9-5 as well, but it's possible. And additionally, study for tomorrow. So let's go ahead and try to use today to the best of our ability. I know we have a few choir people that are gone today. I'm just making sure that I have the attendance down correctly. But let me go ahead and get section 9.5, the evens, up so we can grade them. We're going to try and go over as many questions as you guys have today. I'm going to try and explain as best as I can, but I also need to make sure that you guys have highlighted the important stuff to have memorized for tomorrow. Just basically reminding you of all those formulas I told you before break. Does anybody have a way that they studied formulas over break? Just make it real. What's a way that someone studied formulas over break? Uh-oh. Almost positive at least a few of you studied. Do you want to do the whole volunteer thing instead? Did anybody at least try to do something to do with formula cards? Quizlet, formula cards, writing them out. Chris is like maybe kind of. Okay. How many of you guys just kind of looked at your notes? I just looked at your notes. Okay. Okay. That's not bad, but some of your brains, like if memorizing is hard for you, some of you need to start activating the kinetic part of yourself as well, and not just the intellectual, not just the memory part, but actually get yourself moving. And when you write out formulas, it really does help. I had, for instance, a calculus kid this morning. They were supposed to, they have, some of you guys have heard of their forever cards. It's like the index cards that they're all colored. They're always studying. Well, sometimes studying. They'll be studying a lot more in the next 3 weeks. But their forever cards, they were supposed to quote them out loud. I have them actually say them out loud because studies have shown that it can be helpful to actually be saying and speaking. Some of you are, let's just say you speak a lot better than you listen. But some people, it's easier to speak things out, and so I actually have them reading the cards out loud 10 times over break, up to 15 for bonus. But I also say that they can write the cards, and a couple people actually took me up on that and wrote every single one. There's 42 different cards. They wrote them all out. It was worth 2 quotings. But I asked them this morning, I'm like, how did it, because they had a huge quiz today. They're like, no, I know it's so much better because I took the time and wrote it out. So some of your brains need that movement to write out, and some of your brains maybe just speak it out loud. Because when you read something, isn't it so easy to get distracted? I don't know if any of you guys actually try to read your Bible, but I don't know about you. But when you try to read your Bible in the morning, my brain is just like zoom, 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 zoom about what I'm supposed to do for the day. I have to keep on being like, Lord, help, Lord, help, Lord, help me to focus. It's kind of similar when you're studying. If you're reading it, it's so easy for your brain to be like, oh, this is dumb, or even just thinking about other important things and not focusing on what you're actually looking at. So if you have someone asking you and you have to say it back to them, if you're just reading it out loud, if you're writing it down, if you have some sort of like Quizlet app or flashcards where you can be like, do I know it? Oh, I do. Oh, I don't. Just think about that tonight for tomorrow, okay? Here we go, section 9.5, let's grade real fast. Number 10, final answer is 792. Not sure I would have mental mathed that one. That's kind of a big number, but we could have, breaking down the factorial. Number 18, you could have done Pascal's all the way down to the 10th row. Now, some of you are like, that was so dumb. Why did they have me use Pascal's? Well, once you had it written, couldn't you use it in other problems? Maybe that's why they had you write it out. But anyway, the final entry would have been 45, which you also could have done 10C, R is 0, R is 1, R is 2. This would have been the x to the 10th, x to the 9th, x to the 8th entry. But you could have just counted over the 3rd one in the 10th row. Number 24, you were supposed to expand it. Remember the direction expand. Expand means multiply out, and ain't nobody want to actually multiply that out, right? So what's the trick? Go down in the powers of y. Good. What do we have to do with this negative 2, though? He has to be brought in. Y counts down where negative 2 counts up, starting at 0. He's not there to begin with. But then all of a sudden, he is there. Wait, I don't see the negative 2. Oh, he's right there. The signs are with the negative. The sign, a negative squared is positive. A negative not squared, not to an even power, will be negative. So that's where the signs went. But otherwise, you can see the 2 counting up as you see the y counting down. And then where do you get the special numbers in front? Why is this a 10 and not a 2? Because we had to use the, hey, if you just did Pascal's, you could have just said 1, 5, 10, 10, 5, 1. Or you could have done 5C0, 5C1, 5C2, etc. and solved it. Number 32, very similar, just a little bit messier because you have a 2x and a negative 5y. And so remember, even though the 1, 5, 10, 10, 5, 1 is a part, you have all these other numbers that are in there as well as these terms get raised to different powers. Last but not least, is that our last one, number 50? Oh, nope, it's not. The last one on this page, number 50. The fifth term in the expansion. This one would have been a little bit hard, unless you thought of what's going on in the fifth term. Because remember, we're starting with our formula NCR with x to the n minus r and y to the r. But in this case, we had 5a and 6b, so we would have replaced the 5a and 6b with our x and y. 5a, 6b. We would have seen that n is equal to 5, so we would have replaced both of our n's with 5. And we can jump without having to do all the work by asking ourselves, who on earth is r? If it's the fifth term, r would be 4 because r always starts at 0. So you could say 0, 1, 2, 3, 4. So you could have figured out that r was 4 that way. Plug in 4, 4, 4. And then at this point, you can just solve by simplifying. Or you could have said, okay, hold on, the fifth term, well, this guy, the 5a starts off to the fifth power. That's the first term. Fourth power, that's the second term. Third power, that's fifth, fourth, third, second, first. He needs to be to the first power. Oh, to be to the first power, 5 minus r must be 1. R must be 4. There's a few different ways of doing it. But it's going to be really helpful to be able to jump to a term instead of having to do all of Pascal's and solve it all out. Like number 32, and then after you have it all, then say 1, 2, 3, 4, 5. Yay! We didn't want to do that whole process here. 54. Super similar, jumping to a term. What made it tricky was in this one when we were trying to do our NCR formula. Let's see if I can fit it up here. NCR, hold on, we have x squared being raised to the 12 minus r. 3 being raised to the r. I'm making it particular for what I see. I'm changing my n to be 12. Trying to change my n to be 12. They told me I need x to the 8th. How do I find r? Where's my x up here? Right here, right? What power is x2? 12 minus r. No. 2 times 12 minus r. So then we would have needed 2 times power to a power you multiply. There's my little baby equation. Go find r. Divide by 2, I have 4. Subtract 12, I have negative 8. Divide by a negative, I have 8. Which is why you see them plugging in r equals 8. And 12 minus 8 is 4. And x squared to the 4th would be x to the 8th. I think we've noticed there's an important guy in section 9.5 we should probably highlight and make sure we have memorized. But you also look at homework/test review to practice a little bit more to get a little better with jumping to a certain place in an expansion. It'll save time. Last but not least, what we got? Number 88. Number 88 was a big old plug and chug. I don't think there's one specifically like 88 on the test. Remember, this is a 75-point test. The majority of Chapter 9 is on this test, but we have a little Chapter 9B quiz worth 25 points a little bit later, because probability I separated from the rest of the chapter. Okay. Any questions on odds from section 9.5, or evens that you don't think I explained well enough? Can we pause real quick since we've just done the homework? Can you guys open up your notes? I see Jackie doing this, and this is a great idea. Can we just open up our notes real quick and be like, hey, what was important? What is important to memorize? I'm going to go to the review in just a second and see if you have any questions on the review. But while we're thinking about it, let's pop back into our notes and say, okay, hold on, what's important? So in our notes, there aren't really tons of notes for section 9.5. It was mostly examples. Do you think you need to get to the point tonight where tomorrow you can recite to me this entire line of formula? No, that's not how this class works, right? You just need to be able to do it. But what do you think is something that's really important to memorize? I would say the general term, yeah. How we jumped. We jumped using this formula right here. We jumped saying, hey, to get to any one term, to get to any one place in an expansion, you can think NCR, x to the n minus r, y to the r. But it might be helpful for you to take that general term and kind of talk about what is going on. So if you want to add to it just a little bit, I would highlight this. But for some of you, this doesn't mean anything unless you start actually labeling stuff. Like, n is going to be the power of your a plus b raised to the n. Some of you need to actually say that to yourself. Like, hey, when I'm actually raising something to a power, this power goes right there. And it's also going to go right there. Maybe it'd be helpful for you to actually say, hey, this is going to be the first term. And specifically, the first term is going to be a. So whatever's in this first spot is going to go in that. And this one is our second term. You might want to write yourself a quick little note as far as watch out for the negative, because if there is a minus in the a plus b, I need to put a negative in there. And then you might also want to make a quick little note to yourself that in the expansions, remember, R starts at 0. So the first term, R is going to be 0, then R is 1, then R is 2, then R is 3. And maybe they'll give you clues, and this is when you go to the homework, this is when you go to the examples, this is when you go to the review, or the book examples, not just our note examples, and say, okay, wait, I know it got tricky to figure out who R is. Let me go back and recap. But you need to have this memorized first, or else you can't jump anywhere. And you need to know the basics of, okay, n comes from there, x comes from the first piece, y comes from the second piece. If there's a minus, I put a negative in there. R comes from, well, they're going to have to give me some sort of clue as to what R is, as to how to jump, and that's when you go look at the problems to help yourselves out. Okay, I would highlight that and maybe label some of those that we just talked about, but there's one more thing I would highlight in section 9.5, and that's the NCR formula. Tomorrow there's going to be one page, just one side, not two sides. I think it's like 4 or 5 multiple choice. They're going to have to be able to do without a calculator. So we're going to start off with the non-calculator portion, just 4 or 5 questions, one side. But let me give you a hint. One of them is going to ask you to use this formula. Okay? But as soon as you go to the calculator portion of the test, it's one more piece of paper, just a front and back. It's not super long. The calculator portion, now you can use your, hey, where is this in your calculator if you're allowed to use it? Do you remember? Math. And then you have to go, over to probability. So as soon as you can go to the calculator portion, don't go back to this formula. It's okay. You can just plug it in your calculator and find it quickly. But on the non-calculator portion, I am going to ask you to use the factorial formula. Does that make sense? Okay, just so that you're prepared, you know what's coming. I don't want to have any crazy surprises tomorrow. Other than that, if you can do Pascal, some of you think it's faster than using the formula, and that's okay. But I think the rest, guys, I think they were all just practice. So section 9.5, 2 things. Maybe 3 if you like Pascals. 2 things, maybe 3. Have the factorial formula down for NCR, and have the general term as far as how, as far as how to jump to a certain place. Otherwise, remember, if it says expand, you're finding the entire thing. Kind of like, let's find an example of that. That just says find a term. Those just say solve. Here we go. The expansion is the entire multiplied out, everything simplified, ready to go. That's an easy example, though. This is a great hard example for how to expand. Okay, since we're in our notes, let's go ahead and go back and highlight a few more things. Let's go back to section 9.4. Exactly. Hey, go team, one less thing to study. Go back to section 9.3. Do you guys remember 9.3, 9.2, what the goal was? Zoom in on arithmetic, that was 9.2, and zoom in on geometric, that's 9.3. Geometric, we have a common, who's this guy? Good, we have a common ratio. And with the common ratios, we basically, in 9.3, we have 3 formulas we got to know. The first one, and if I can hit the right page, this formula. If you don't have it highlighted yet, highlight it now. How to find the nth term. Remember, a sequence is just tons and tons and tons of terms. If they want us to jump to the 20th or the 50th or the 7th, we need to know the idea of geometric. The first term times the common ratio to the n minus 1. Remember, if we're trying to jump from the 1st to the 5th, there are only 4 jumps. It's always 1 fewer than the place that we're at. What's another important formula, though? Can you guys find another one? Yeah, geometric series. Good, the nth partial sum. The geometric series, the nth partial sum. The most important part to know, guys, on this one is the n formula. Look up here and peek real quick. Is this n formula? Because the series, if it's a calculator portion, could you plug that series into your calculator? The answer is yes. If I have a blank asking for you to actually, I don't know why my orientation is off. It's literally been less than an hour. Anyway, if I have a blank asking you to solve it with the formula, I could even do that on a calculator portion of the test, and for you to get full credit, you'd have to fill in that blank as well. So be ready for that, but also know how to use this function in your calculator, just to double check. We go to the math, right? And then don't we just scroll down to 0, the summation? So make sure you know how to use that one. However, just a heads up, I could ask for something like show me the formula, solve for the nth partial sum, showing the formula, where you plug in the common ratio, you plug in the n, you plug in the first term, and solve, solve, solve. There's one more important formula, and it only is possible with geometric. And that was this entire page of finding the infinite sum. So you could have an infinity. It could show up like this. Or it could also show up like, oh, bummer, I don't have it on this page. Here we go. Or it could show up as a dot, dot, dot. See how this guy never technically ends? So whether you see an infinity up in the summation notation, or whether you see a dot, 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 that should point you to this idea right here, which is how to find an infinite sum. Now here's the struggle. Infinite sum, do they always exist? So then we have to know the whens. We have to know the whens, because if I ask you for an infinite sum, whether it's an infinity here, or whether it's a dot, dot, dot there, if the common ratio is greater than or equal to 1, if it's 3, if it's 2, if it's 1.00001, that sequence is divergent. That sequence diverges, and there is no sum. But if the r is in between -1 and 1, then the series will converge. It's convergent, which means the sum exists, which means, for those of you that don't like all the calculus limit notation, you would plug into this formula, you would memorize a new formula. For those of you that it kind of made sense, you could just use the old formula that we memorized from the nth partial sum and just have this little piece go to 0, which it will always do. whenever the series converges. So you could just memorize a whole brand new formula, or you could use the old formula, and remember, whenever r is in between -1 and 1, this goes to 0, which means yay, just plug in everything that's left. Whenever you plug that in, it would not go to 0, so therefore the sum does not exist, DNE. That's section 9.3. 9.2 is even easier than 9.3. Let's go back there, because the arithmetic sequences in series, they don't have this whole infinite idea, so it's even easier. But still 2 formulas for us to remember. Remember, arithmetic, the arithmetic ones, they have a common difference. You're adding this time. And with the common difference, yes, I'm not going to quiz you guys on recursive formulas. I might have a question on there that asks if you know how to do a recursive formula. Like if I give you a recursive formula, let's see. What's a quick example of a recursive formula? I'm not sure if I necessarily asked that one. Try to get an example up there. What if I said something like, write the first 5 terms of a sub 1 is equal to 5, and a sub k is equal to -2 a sub k minus 1 plus 3. Now, this one isn't actually arithmetic, it's just a general one. This would be like from section 9.1. But how would you write out the first 5? I know the first one, he's 5. What's the second one? What am I supposed to do? Good, because we take the 5 and we plug them in where? To get to the next term, we have to plug in the previous. So plug in 5. What's -2 times 5? And what's -10 plus 3? To get the next term, I have to do it again. But now I'm plugging in -7. So -2 times -7 is 14 plus 3 is 17. Now I gave you a hard one. But do you get the idea of recursive? You just plug in whatever the last term was and do the pattern. Michael. Oh, you have to multiply it by... The -1 just means, hey, now you want to find the third term. So if I wanted to find the third term, which is what happened when I plugged in, to find the third, I need to plug in the second. Does that make sense? So the -1 is in the notation. It's not in the math. Okay. That was kind of a good section 9.1. We'll go over that in just a second again when we get to 9.1. But for right now, we're all doing arithmetic. All have common differences. If it didn't have a common difference, it would not be arithmetic. But we do have 2 formulas. The nth term, just like geometric, the nth term, and the nth partial sum. Just like geometric, it's n minus 1 jumps, but this time it's jumps of d, so we're adding this multiplication, whereas with geometric, we're multiplying the n minus 1 jumps of r. Where's that nth partial sum formula? Did you guys already find it? This is the Gauss one. This is the little kid in the classroom who did the problem real fast, and the teacher was super annoyed. You add the first and the last, multiply it by n minus 2 jumps, or n minus 2 pairs. Because remember, you're going to pair up in order to get that sum. That's how we add the first and the last. But since it takes 2 to make every single sum, then we just have to divide by 2. And if you have to find the nth term, there's that snazzy formula for that. So 2 formulas from 9.2. And then 9.1 introduced the entire thing and said, hey, there are these things called sequences and series. There's not really much to memorize in this section. And I told you guys 9.1, anything that comes from 9.1, it's kind of broad and it's kind of hard. Remember, BC kids had to do a lot of work with sequences and series this year. So on the test, if I was to ask you, let's see, what was the hardest type of problem? How to plug in? No, that wasn't too hard. What recursive formulas look like? We did okay with recursive. How to jump, even how to use your calculator. I won't force you to do that tomorrow. But maybe how to know a pattern and say, oh, the pattern is take the last 14 and multiply by -2, jumpity jump, jump, jump. How to look at a formula and know the jump you're supposed to do. I mean, how to work with factorials. We practiced that a lot this chapter, so I guess that's important. Nothing to really memorize, but maybe some good problems to practice with factorials. Don't need to know any of these properties, but maybe how to plug in both to your calculator and by hand, how to do a sigma, how to do a sum. But what was crazy, where was it? It was that n squared minus 1, 1. Here it was. This one, the pattern was really easy. I think, Joel, you were the one helping us on this one. The pattern, you saw the pattern real quick on this one. It was the plus 3, plus 5. But it took us a long time not just to see the pattern, but how to make a formula for the nth term. If I ask you something on the test where I give you something nasty, it's not arithmetic, it's not geometric, and I ask for an nth term formula, it's going to be multiple choice. If it's going to be multiple choice, what could you technically do? Look at the answers and plug in and figure out which one works for the sequence or series I gave you. So if it's not geometric, if it's not arithmetic, this one wasn't plus 3, plus 3, plus 3, wasn't times 3, times 3, times 3. It was different. If I give you a different one on the test, it'll be multiple choice. I'm just asking, can you figure out which is the right one that matches it for every single term? Does that make sense? Okay, so just knowing how to plug in and check. Guys, that's it. 9-1, basically how to plug in and check and be able to read a sequence versus a series. 9-2, hey, there are these special arithmetic ones with common differences, 2 formulas there. 9-3, there are these special ones called geometric with common ratios. There are 3 special formulas there. Nth term, nth partial sum, there's that infinite converging, diverging thing. Sometimes there's a sum, sometimes there's not. And then N5 is the whole binomial theorem of Pascal's triangle, how to jump to a term, and NCR formula. Hence why I advise strongly over spring break, work on those formulas that way. You guys could, just tonight, make sure everything is polished and ready to go. But once again, if you didn't have time over break, didn't use time over break to practice, to finish your reviews, then work, and as you're working, be memorizing those formulas at the same time. Kiddos, we're at the review. Did you get stuck? Where did you get stuck? Do you have any questions? Yeah, I can. Would anybody else appreciate that one? Okay. Thank you, Lainey. Let me get rid of this, and I think I have the review questions right here. All right. I'm okay letting us have 12 minutes to work, but I'm more than willing to answer any questions I can. Yeah. Sadly, I think my one from the office ran out. But I do have paper towels at the front. Yeah, Jackie. No. But could it be helpful for some of you to, like you do in languages, to make flashcards to study? Yes. Yes, yes, yes. But no, it needs to be memorized or understood for tomorrow. Yeah. So you're going to start off with the calculator under your desk. I'm going to pass out the non-calculator portion, which is just one side, 4 to 5 questions. And so you have no calculator for that portion. Then you come up, you turn that in. Don't staple scratch paper, just keep it for the whole test. Pick up the calculator portion, pick up your calculator. You can use it the rest of the time. But if there are any blanks on that, make sure you fill in like with whatever I'm asking. All right, you guys okay if I put up the review and you can use it up here? Or you can come grab a book if there's time. Anybody still writing down the problems? Yeah. Okay, a couple more moments.